Now, good morning, Hacksters! We are here today with Che-Wei, Wang, and Taylor Levy of CW&T Hardware Design Studio. The hardware design isn't actually part of your name. That's just sort of like my description of what you do. Would you care to introduce yourselves and sort of what you get up to?
Go Taylor.
Sure. My name is Taylor. I am an artist and a designer. I have like a long passion for sort of the low level, like the way computers work. That's my. I have a deep passion for that and sort of uncovering the mystery and the hidden beauty that lives inside of our encapsulated devices. But Save and I have CW&T together, where we make art and design objects, sometimes design objects or art objects that are disguised as design objects. And yeah, thanks for having us, Alex.
Oh, yeah, thanks for joining.
I guess I'll introduce myself. I'm Che-Wei. Well, Taylor and I are normally in the same space. We're also partners in life. I'm just at work today, my day job. My background's in architecture. I studied architecture and have taught architecture for a while. But my passion is in making objects. So I kind of stumbled into using electronics, but I enjoy it quite a bit because it's quite powerful. But I really love just making stuff that I want for myself. And so our studio practice is kind of built around that. So we don't, we're not trying to make things that have mass appeal, but we're just trying to please ourselves and make stuff that we really want in our own lives. And then we try to find an audience that appreciates those things as much as we do.
That makes total sense. And your intros really fit with what I see you making. So this is the CW&T website. And first up, there's this super local clock that we'll talk about in a second that you're actually kickstarting right now. How's that going?
Good,
Going
I think. Yeah.
Yeah.
But I also, Taylor said something that I wanted to relate to one of your projects, the time since launch. So you said that I loved how you said this, something about uncovering the hidden beauty inside of the technology that we have. And I feel like some of your electronic projects really exploit that beauty with these transparent enclosures. Could you tell us a little bit about this project?
Yeah, so time since launch, I guess time since launch also falls into the category of an art object that's disguised as a design object too. But one of the main ideas behind this project, well, let me first tell you what it is. Time since launch, it's a single-use launch clock. You get this thing, and then you can kind of see in the back of that picture, there's like a little pin. You get it, and there's nothing on the display. Well, there's like a little screensaver mode on the display. And once you pull the pin, this device starts counting seconds, minutes, hours, and days up to 1,000,000 days, which is over 2,700, I think 2,738 years. And yeah, so it's this idea that you can mark your moment zero for and like start this sort of like large scale timing or epoch based on something in your life. So like maybe it's time since I ate pizza, time since I quit my job. A lot of people use them when they get married or if they have a child or when their child starts walking. But it's this idea of like setting these time meridians, these moments that are very personal and personal to you, and not necessarily something that like the entire like society decided was important. But I guess to go back to your question about the physical design of it, yeah, we're really like we want this thing to last. We like the idea that when you buy something from us, you actually own it, and it's not. Like we don't put our branding on any of our products because we don't want you to buy something that says our name on it. I mean, it is yours. But that also follows with it. Like this thing should last you a really, really, really long time. And because of that, like it's an electronics piece, but everything, all the functionality is fully visible. So if something breaks, like maybe your chip breaks or maybe an LCD pin gets unsoldered or something like that, that can be physically obvious, and you can send it back in and we'll take it apart and we'll fix it for you. Or if we're long gone, like somebody can inspect it and be like, I think I could just solder this little thing and it'll start working again. So we like to make everything that we design as legible as possible, so that, like, the construction behind it is visible.
That's
also.
awesome. That also shows up in this solid state watch that you've created, which is a Casio watch, a standard Casio that's embedded in this resin. Could you tell us more about this project and what that means to you?
Do you want to talk about Che-Wei, or do you want me to talk about it?
Go Taylor.
You want me to talk about it? Okay.
Yeah.
So this project, it's also an art project. It starts as really a celebration of the Casio F91 movement, which, like, if you design stuff with electronics, this thing is like, it's a marvel. It works. It keeps precise time, like very, very precise time. It costs, first of all, it costs like $10, $13 maybe to buy this Casio watch. And it will keep time accurately for, I forget what the parts per million are of this specific one, but it's pretty amazing.
2 parts per million.
What is it? 2 parts per million?
2 parts, yeah.
Wow.
What does that translate into in terms of like human understanding? I remember there was
it's like a few seconds a month.
Okay. Which for something that's that inexpensive, it's like, and also it will last on the same battery for 10 years. They've been known to last for even longer than that. Which, like, I don't, like, nothing that we'll buy today, except for something like this, will last for that long, and will work that well for that long. Like our computers, I don't know, we cycle through them and we have to maintain them, and they kind of become like obsolete. They become obsolete very quickly. So the idea behind this was just really celebrating this idea of that, like, Casio is able to make this like beautiful piece of electronics, and we're encasing it in resin.
Yeah.
So over time, this thing will decay, and that's kind of like part of you acquiring this object. Like it will drift. Like right now, I'm wearing one actually, and I think mine says 9:31. Mine's 6 minutes late, so I'm always like when I'm getting my kids to school.
Oh no!
I have to remember that I'm actually later than I'm not on time right now. I'm actually 6 minutes later. But it's this idea of building this sort of essence, like this sense of electronics obsolescence into the product, and having you, like, we buy into it without acknowledging it all the time. But this is a way of like actually acknowledging that and living with it and actually feeling that electronic decay and the gradual obsolescence. Because one day this thing like will die and it's cast in resin. I can't replace the battery, and that'll be that.
It's just such an interesting interplay for you, because you're, on the one hand, you're creating products, so you're prototyping, but on the other hand, so many of your products have this kind of like a no going back kind of idea, where like this one is potted in resin, you can't change it, you can't resolder it. The time since launch, there's no way to stop the clock or like restart it or anything. Like once you pull that pin, you're done. How does that interact with your prototyping process?
That's a good question. I never really thought about that. I never even thought about that concept as something that lives in our work. Prototyping process, I guess. Yeah. Well, with time since launch, like we can kind of cheat it. You know, like you're right. There's a lot of like we don't know what this thing is gonna be later on, right? So with time since launch, like we come up with this idea and we're really firm in it. For example, a lot of people come to us and they're like, I launched, somebody actually emailed the other day, was like, the flower girl at my wedding pulled the pin 9 minutes before.
Oh no!
Well, can you fix it for me? And like the short answer is like, well, the secret answer is like, yeah, we could, but the real answer is like, no, we don't do that, because it's really about like just opening yourself and celebrating these like very human moments, and embracing that like that's life, you know. You're supposed to be present in this moment, and when you activate one of these devices, and that will become part of the story. And like our histories are human and they're imperfect, and they're full with stories like that. And I think it just enriches this piece in a way that, you know, like it adds more to it than, for example, being like, yeah, I can like Band-Aid that and fix it for you. It's not, I think there's something poetic there that's lost if we were to Band-Aid it up.
Yeah.
But we
It's kind
also
of-
don't do it because we, it's partly to maintain the, like not a guarantee, but like the knowledge that if you ever see a time since launch device anywhere in the world, you know that someone was there at that moment pulling the pin. Like we don't backdate them for that reason. You know, otherwise you can just, you know, otherwise it's just like another LCD display. You know, like there's a million of those, but ours is different because we don't allow you to reset it.
Imagine if someone took one of the random thought, because it's early in the morning for me, but I'm just thinking about if there were like a pair of people that each had one and one of them went off like space traveling at like light speed. And
yes, that's actually the original design of this, was to be shipped in pairs.
Oh, wow.
Yeah, so it's actually, maybe we never posted images of this, but the original design was actually a single PCB that was perforated down the middle. And the idea was that you would start the stopwatch when you break the two PCBs apart. So there'd be a trace that you're breaking, and the breaking of the trace actually starts both of them. So it guarantees that they're both synchronized when they start.
Wow.
And we wanted them to drift. Like, you know, it's impossible not to let them drift unless they're syncing with some external source. But that was part of what we thought was really beautiful, is that over time you would see how much the crystals are drifting. And if you did take one to orbit Earth for a few years, yeah, you would see a significant difference.
Wow, that's so cool. Let's see. Oh, I had my next. Oh yes, super local. Let's talk about this, because this is in my mind kind of the opposite, where like usually we see clocks as this very fixed things, and a lot of your objects, art design objects, secret art objects designed as, or vice versa. Anyway, I want to get into that later. Like, what's the difference between art and design objects? But in terms of this clock, we usually see clocks as very fixed things, and like you get the clock, it has this idea of time, and that's what you get. But this clock is kind of the opposite of that. Could you tell us about it?
Yeah.
Should I talk about it?
Yeah, go for it.
Wait, sorry, what was the question? What is this about?
Yeah, if you could just,
Yeah.
I have my idea about this, which is that like it allows you to sort of put your own imprint on your clock and how you measure time. But I'm
Yeah.
curious, like what you
You nailed it. I mean, it's really, I think we stumbled into that. Like that's sort of the way we imagine we use this thing, but we stumbled into it. Like this. It was originally prototyped as a clock for our kids, because we wanted to, you know, it's really hard for little kids to understand what time it is. And we had this problem where the kids would be waking up really early in the morning and waking us up, like jumping into our beds.
Oh, no.
So what we did was we made a prototype of this clock, looked quite similar actually, with a 24-hour movement, which is the key. So 24-hour movement, and then we just put a sticker at, I think it was like 7 o'clock or 7 or 8 o'clock, where we're like, hey, on weekdays, unless the hand passes this dot, don't come wake us up. And it worked. Like they immediately understood, and they would, you know, they would look at it and talk to each other about like, oh, is it on the dot? Is it not on the dot? Do we get to go now? And like we would hear them talk about it. And it kind of snowballed from there. We're like, oh, this is actually pretty cool, that, you know, you don't have to know how to read a clock, like, you know, understand the relationship between the minute hand, the hour hand, and all the tick marks. We can just make a single hand 24-hour clock and just put the markers where you want them, like where they're important moments of your day. So for us, we always, you know, we encourage people to start with one for where you wake up and one where you go to sleep. And I think that immediately kind of shifts your perception of what your day looks like relative to a 24-hour cycle. And in my head, it works so well. Like that part we weren't anticipating. Like we weren't anticipating it to be used as like a visualization of your day, but it works really well that way. Like you can see, how much of your waking hour you're spending, between your wake up time and lunchtime, for example, or like lunchtime to dinner time. You can kind of very quickly see how you're splitting your day up. And that was eye-opening to me. And so, yeah, we were like, oh, maybe this is something. So yeah, we're putting this out there to see if maybe lots of people will use it the way we use it, but maybe people will find other interesting uses for it, because it is essentially just a blank clock. And you get to put your markers however you want to put them. So maybe people will come up with other interesting uses.
And you're right. I did basically just read off the blurb that you had there. I'd already like congealed it into my mind. So for a project like this, are you making your own electronics for the clock? Are you using something off the shelf? I know that you have you clearly have very particular, like, you want it to be good. You want it to be the right one. I'm curious what decisions you make based on that.
Well, when we were prototyping this, we were also helping Scott Thrift, who's an amazing person and is the creator of The Present. It's this beautiful rainbow gradient clock that people have probably seen. It used to be in the MoMA store, maybe it still is in the MoMA store. It's a pretty popular project on Kickstarter. Anyways, we were helping him design the new version of this clock. Yes, exactly, this clock. So we helped him a little bit on this version, and then the newest one, which is made out of cork. So there's a small desktop version that's made out of cork, and then a wall mount version that's also made out of cork, and we helped him design that. And so we had a lot of his parts lying around. So we had his movements, which he sourced from a German manufacturer, that are excellent. And so we had all this stuff lying around, so it was really easy to prototype the clock that we were messing around with. And so, yeah, we're just going to use the same movements that he had sourced and kindly shared with us.
Sweet. And when it comes to custom hardware projects like this one, where do you start? And what? Obviously, you start with the idea, probably. I don't know. Or do you start with an experience? Could you tell us about your prototyping process?
It starts with just messing around. So that little squarish, rectangular-ish one that's in there, yeah, that one. So that's actually one of the first prototypes. So before it was two pieces that was breaking. The first test was just like, how do I even drive a display? So this is an e-ink display. So it's similar to an LCD. You have to kind of drive every single segment. So that's connected to a Atmega chip. And then you could see there's a tiny crystal there. So it's not, it's very bare bones, low budget, just like trying to figure out if this is even an interesting idea. And obviously I made some mistakes. So there's I had to jump some pins there. But in this version, the idea was that because it's an e-ink display, we had this secondary idea, which was that you could actually stop it, but you only get one chance to stop it. So to stop it, you have to break the PCB again.
Wow.
And then the e-ink display would always show where it was whatever it last displayed, because there's nothing, you don't need power to keep the display up. But yeah, it starts with that, just like messing around with something functional. And then in parallel working, the one to the left of that, I think is maybe another early prototype where, we started machining parts and getting, trying to get the form factor right. I think in that version, it was still an e-ink display. And then it kind of sat on the shelf for a few years. We, e-ink displays are really expensive. They're very relatively interesting, it's power hungry if you're trying to refresh it every second. It's not really meant for that. So and we hadn't worked with LCD displays, so we kind of just let it sit on the shelf for a few years until we met this amazing electrical engineer. I was like, hey, I can help you with that thing, because we knew we wanted this thing to last and get, drive for a really long time, like not just a few years. Like that didn't seem right to us. Like we wanted this thing to run for decades. And so we, that was kind of outside our wheelhouse of like figuring out how to do low power electronics. Like we had done some low power electronics, but really needed like super low power electronics.
Yeah.
And so we met someone who's since become a really good friend and has helped in a lot of things. And he took on that part of the project and really made it insanely low power, like lower power than how much the battery is just draining when it's sitting on the shelf. Like it
Wow.
uses less power than that. So yeah, he totally changed the, like, this possibility of this becoming a product kind of just, we just like leapfrogged and just stumbled into it. Like otherwise we wouldn't have been able to do it.
Are there any other considerations besides battery power that go into designing a piece of electronics that's going to live for 10 years?
Yeah, so much. And so much that we learned along the way. Like in the beginning, we're like, oh, we just have to figure out the low power stuff. And then it was like, oh, actually humidity matters because LCDs are very sensitive to humidity. So if you want this thing to last for a really long time, you got to seal it properly and make sure there's no humidity in there. In the beginning, we were thinking of putting some desiccant in there, but at this point, it's basically just an airtight seal. So as long as you're not pulling this pin in a crazy humid environment, it should be okay. There's also some static issues, so making this thing resilient to static was an issue. So we had to change some electronics mid-production because we stumbled into a static problem. Like we realized some things were happening. We were cleaning these things as we were shipping them and like rubbing them with a microfiber.
Oh no!
And then it would
Which is the classic rubbing a rod of glass or
right, exactly.
Oh,
it's
no.
like the perfect way to generate tons of static. And it would really mess up the electronics. So we had to go back and figure out how to undo that. And that took a little bit of experimenting and prototyping again to figure out why the static was messing things up so much. Those kinds of things.
Do you mind telling us what microcontroller is in here? What are you using that's going to work that well?
I think this is an Atmega, Xmega. So again, we're just, there's no LCD controller. We're just driving every pin directly from the microcontroller.
Wow.
And we just needed a chip that had enough pins to do that.
And what are your favorite tools to work with this? If you're designing the PCBs by yourself, for example, I know that you're working with an engineer, but you seem to also do some of the design work yourself. I'm curious what your preferred tools are for that as aesthetes.
We used to use a lot of Eagle.
I use a lot of Eagle still.
Yeah, it's integrated with Fusion, so now I'm all, like, everything's in Fusion for me, all the CAD and the electronics.
Does that help you out because you can do the PCB design and the CAM in sort of one application?
Yeah.
Or do you not use that?
Yeah, we use it, or I do. Yeah, like so. All the figuring out how the PCB relates to the hardware, and then we also do the camming for the hardware to then machine it. And it's just really nice that all of that is fully integrated. So yeah, maybe for the last year or 2 years, I've been using the Eagle that's inside Fusion.
Cool. I want to show off some other things that you have in here. Where is this? There's the ones site. So if people are wondering like how like intense you can get with like getting the right thing, you have this really intense focus on like having the right one and it's gonna last you like forever. So could you tell us about this project, the ones?
Taylor, you want to talk about it?
Where did it
start?
Yeah,
sure. I guess it just started a really long time ago. This list of like
started during Hurricane Sandy.
Did it really? Yeah.
Yeah, because we were indoors and didn't know what to do with ourselves.
Yeah, I guess so. And then we just started kind of like taking inventory of our. I guess we weren't even able to go to our studio. We just started taking inventory of like the best thing. It was also at a point, I guess, where we like moved in together, and like I had all my like shitty college purchases, and he like for some reason was like, or not for some reason, he was like a little bit fancier than I was, and had a house that he lived in more like an adult for longer. So he had already some purchases that were proper. Like he had purchased a chair and that kettle, for example.
Mm-hmm.
He's like, this is the nicest kettle. And I really like, it's very stupid and obvious, but like, it's like, this is it. Like, this is the last time in my life that I'm going to buy the like cheap version of a thing and then have to keep buying it every few years. Like, I'm going to invest in the proper thing. And like figure out how I can afford that. Like, because you can't always get the best of the best, but this was sort of just like our beginning list of those things. Like that glue gun, best glue gun.
That's a really sweet glue gun.
Yeah, it's expensive, but man, I mean, yeah, how many crappy hot glue guns have we been through, and then now we don't have to deal with crappy glue guns.
Yeah, that thing
now you get
so
this
good.
like sweet diesel punk aesthetic as well. This looks like it came from your architecture days, maybe, because they call it hot melt. Is that a thing?
Well, yeah, technically it's not a hot glue gun. It is a hot melt. It's a different kind of glue than hot glue.
So anyway, people, if you want to find the best calipers, the best heat gun for rework, the best radio, this is a really interesting one, then this is a great place to look. You also make lots of devices that are not electronic. There's there's a bunch of ones that we can't go through, but you make your own jump rope, for example. It's very interesting. So we're at about 17 minutes in, or no, 12 minutes in. My sense of time is all wonky. 27 minutes in?
Yeah, we're 27 minutes in. Almost half an hour.
Thank you. Anyway, it is time to do our collaboration with SparkFun, which is our rapid round. So we're going to start the timer here, and then you'll have 1 minute to answer as many questions as you can about rapid prototyping. So fast and loose is what we're talking about here. We'll have a few minutes afterwards to talk about any of the ones that get especially exciting and meaty. But I'm going to hit this button, and then, well, you know the drill. Okay, so favorite open source tool?
What? Arduino, I guess.
Yeah.
Cool. Best piece of advice from a mentor? You're going to lose time on this one.
For a mentor?
Oh my God.
From a mentor.
From a mentor. I don't know.
Okay, let's skip that one.
Next.
Peanut butter, smooth, crunchy, or no?
Crunchy.
No peanut butter for me.
Okay, cool. Worst piece of advice you've received?
What? Skip.
Okay, these ones are time killers. What is the hardest part of getting an idea to market?
The last part.
Perfect.
The last 2%.
The last 2% and getting it perfect?
Yeah.
Okay, cool. What's your biggest manufacturing snafu?
Oh, just not knowing. A long time ago.
Yeah.
That's legit. So you were just sort of starting blind and didn't really have any experience?
Yeah.
We were, I think, too trustworthy of blindly trusting manufacturers, which is, we were very naive in the beginning.
Ooh, what did you run into because of that?
We gave a manufacturer in China a massive order because
for first Kickstarter project.
Yeah, our first Kickstarter project, and they, he was nice. We met with them, but we didn't observe their manufacturing setup. And he said, "I can make this thing, no problem. 6,000 routines, no problem." And we took a trip there where I got held in Macau because I have passport problems. But Taylor went with my mom and discovered that it was not what they said they were doing. Basically, yeah. So we had to switch manufacturers once. And then another time, because there's, once we switch manufacturers to a little bit slightly more reliable manufacturer in China, this is in 2011. Things are different now. They we had to take them to court.
It was actually
later.
worse the second round.
Yeah, it was worse.
Oh man.
Yeah, they, in the beginning we're like, oh, we're being rescued. They're actually gonna make this thing, and then 2 years into it, they ended up delivering, but a lot of it was out of spec. We had to we had to compromise quite a bit, and then they started ripping us off right as soon as our contract ended. So we had to take them to court, and thankfully they were a U.S. based company with factories in China, so we were able to take them to court.
Mm-hmm.
But nobody wins when you go to court. The lawyers win when you go to court. So
Yeah.
we paid a lot of money to a lawyer for them to stop making our products, basically. Yeah.
So that sounds awful.
Yeah, it's terrible. I do not recommend having to go to court. It's not. It was one of the most stressful periods of my life ever.
Not the best part of manufacturing hardware.
Yeah.
Then.
Yeah.
Speaking
I think
of
the
your...
worst advice actually is patent your stuff. Patent
Huh.
your stuff. That's the worst advice.
Ooh, could you say
So
more?
Yeah.
To you.
My mom loves encouraging us to patent our stuff because I think that's, I don't know what to say about patenting. I think there are things that make sense to patent. I think in the world that we are in, which is primarily design focused and product focused, unless you're prepared to, unless your product is going to make so much money that it's going to be easy to go into litigation. It's never easy, but it's not worth going into litigation unless your product is making several $1 million, because lawyers cost a lot of money. So unless your product is going to be at that scale and that you want to go into litigation, because you will, I don't think it's worth, we don't think it's worth patenting stuff. We'd rather spend our time making new things. So we've stopped chasing people who make copies of our stuff.
It makes sense. It's sort of where you're putting your value. Is it on your time? Because your time is so valuable, and then you're also dumping tons of your money that you could be using to make other things.
Right.
Huh.
Yeah.
So you have 13 Kickstarters that you've created, which is incredible. When you were talking about the manufacturer issue, was that this pen that you were making, or?
Yeah,
the first pen type A. And if you go to the updates of that campaign, it should be all publicly browsable. There's some epic updates where we talk about all this stuff.
Yeah.
Ooh. Also a lot of cool other stuff about previous later projects. I'm struck by the fact that you say that you don't do branding and you don't put your name on, except on your circuit boards for the I'm gonna call you out on it, because on your circuit boards for the time since launch it does say something about who made it. And you also have this orange dot. Tell us about this orange dot. It shows up in this notebook and also in the watch.
The orange
but it's not
dot
always orange either. It's sometimes gray or beige.
So that it started with the orange dot. It actually started with orange gaff tape that we used to put over logos. And then one day I think Xenolith was like, we should just make a patch that we can just put over to cover logos. And then I don't know, it kind of, whenever we didn't have a logo or any branding, and then we were like, let's just use an orange dot. Because we're kind of not into logos. It was really hard to make one. And then I think it was 4 years ago, we, for the first time ever, hired somebody we hired a studio called Haraf, which was, they're no longer together. The band broke up, but I think we were one of their first clients, and they essentially were like, we want to rebrand you, or not really rebrand you, but we want to come up with your messaging and how you kind of exist in the world. And they came up with this really beautiful design system that you'll see on all of our projects. So all of our projects get this unique ID code that if you kind of go into our website, you can find in the about section, you can find out and figure out how to read that code. It's based on like how many of those things will get made. It's based on the material. It's based on the precision of it. It's based on when that project was first conceived of. And then everything gets a random color, a kind of randomish color.
Oh. I'm beginning to see the light. So having done so many Kickstarters before, I feel like this is an exceptional number of crowdfunding rounds that you've done. What kind of things that you are sort of part of your process now that you weren't aware of at the start that might really help someone out?
For Kickstarter specifically?
Yeah.
I don't know. I think the hardest part about Kickstarter is just getting eyes on your project. Like we have eyes on our projects kind of, but like our projects aren't even like, they're not huge, especially not like how they were at the beginning. But you have to build a mailing list or like a big following somewhere outside of Kickstarter that you kind of bring into the platform when you start. Because it's going to be very hard unless like you have a huge marketing budget and you hire some outside firm, which a lot of people actually do, to get eyeballs on your work.
Right. I remember when there was a sort of inflection point between like Kickstarter being used to kickstart something and Kickstarter being used as kind of a marketing mechanism for something that was already kind of designed and prototyped and produced.
Yeah.
Yeah, I miss those days.
Yeah, I miss those days too. Like for us, like at this point, I mean, like I always wish we were able to launch Kickstarter projects faster and more freely. But like, I don't know. We have everything worked out for Super Local. There's like zero risk. Like these things will ship, and you know they're in production already. They are. Yeah. So,
but you are actually like,
yeah, because of what happened to us at the beginning, like, and I think this happened to a lot of creators. Like Kickstarter really encourages you to get your ducks in a row, but at the same time, that's like at the expense of making things like more inventive with like higher risk. And
where you actually need the Kickstarter to fund it compared to just being a big studio that.
Right. Yeah.
I see. I'd love to ask you about one or two of your other projects, like this one, for example. It's not like a product, but what is the deal with this? What is Xenolith?
Xenolith is it's a device that is programmed to point to any location in the universe in zero gravity. And so what's inside are 3 reaction wheels. So it's the same mechanism that's used on satellites and the ISS to orient itself. And so by controlling the reaction wheels, this is designed kind of like an eyeball. So the eyeball will point to any place in the universe if you just give it a vector. So, and the idea, this is designed with a team at the Space Exploration Initiative at MIT, where I had a part-time gig there that has since ended. And so we had this challenge of making something that connects space travelers to Earth. And so the idea was to have this thing always point to your hometown on Earth, no matter where you travel to in the universe. So that was sort of the seed of the idea, was to have this like virtual tether between, like an astronaut on the ISS where there's barely any windows. So you could have this device always pointing, kind of giving you a reference to where, if you're from Houston, it would always point to Houston no matter where you are relative to Earth. And we're also imagining, you could take this to Mars and, you would always have this virtual tether pointing to Earth.
I love that you could also use it, like if you wanted to always know which way to Mecca, you could like use it to pray.
Yeah.
Oh, these are so cool. And then I just think this is a fascinating part of your experience that I just want to put in there for people to explore further, because we're nearing the end of our time, but there's this really fascinating thing you're doing with the tooth gallery, which again is this sort of like taking something that we see as fairly permanent and instead seeing it as something that you can swap out and like use as an art object that is more temporary. Can you tell us about this real quick?
Sure. So I have a front tooth. I was missing my front tooth for about 3 years, and during that time, friends of ours was like, "Hey, why don't you turn that into a gallery space?" Because the whole time I had already put the implant in. So when you remove a tooth and you want to replace it, you put a titanium screw, like a thread inside, so that you could thread a new tooth or a new cap inside. And so, yeah, they suggested, hey, maybe put out an open call, see what people propose. And we got a bunch of proposals. Like some were ridiculous and not realistic, but we definitely got a bunch that were pretty serious. And so the winning proposal was this proposal to take this artist's great grandmother's gold. So her great grandmother, yeah, if you're interested, there's like a whole write up on this on toothgallery.com. Her great grandmother had taken her jewelry when she was escaping the Ukraine when the Nazis were taking over. And then when she got to Russia, she melted that jewelry to be her teeth illegally, because you're not allowed to do that stuff. And then eventually, wore that gold in her teeth into the US in the 80s, and then replaced the gold teeth with porcelain or whatever, whatever you use to make caps. And then gave her granddaughter this jar of gold teeth because her granddaughter is an artist, and her grandmother was like, I don't know how you're going to pay rent, but you need this jar of gold teeth for rent.
Wow.
And so she's been holding on to this jar of gold teeth for a while. And so when when she heard about the Tooth Gallery commission, she was like, hey, how about you take one of my gold teeth and turn it into your gold tooth and turn it into a tooth for you. And so, yeah, we kind of worked together. And in the end, we decided to take her gold, make it my tooth, but also engrave on it the two words, so lucky. Which is an homage to her grandmother, because her grandmother went through so much stuff. She lost family members over the years. Barely made it out of the Ukraine, barely made it out of Russia. But in her retelling of that story, she's always talking about how lucky she was, not about how unfortunate she was. She's always saying, like, I'm so lucky that I got out of this place. I'm so lucky. Even though my sister died, I'm so lucky that I made it out. And I felt a kinship to that, because I'm also I feel very lucky about everything, like our whole life, and that we get to do the things we get to do. And so, yeah, that's why it says so lucky on there.
Wow, I'm so glad I asked about that. That's beautiful. So we have a little bit of time left, and I have 5 other projects of yours pulled up that are sort of electronic-y, and I wanted to give you just ask you which one of these you'd like to pick to tell us a little bit more about before we wrap up here.
Taylor, you should pick one.
That one, not that one. Not
this
that
one?
We can talk about that one, or maybe let's talk about.
Was it this one?
Yeah, this one. Yeah.
Cool.
This is one of my favorite projects, actually. What it is essentially like the slowest, simplest computer that you could possibly imagine. And it's called 1-bit 1 hertz CPU. Do you want to pull up that picture of it again?
Oh, yeah.
Yeah, it's easier to talk about it if I can reference stuff. So what you're seeing there is there's usually our computers have internal clock that synchronize all processes within our CPU. And those operate at 2 something billion times a second. So they're virtually invisible. Here, the clock that's controlling this mini computer is this 1 hertz AC sync clock or motor at the top. So that thing is cycling and hitting a contact. And essentially the only input, whereas our computer has our mouse and our keyboard, many different types of input. This is a single bit as an input, which is a light switch. And the output is a fluorescent tube light. So you can think of it in two ways. In one way, as like a really slow light switch, because usually when you turn on and off a light, it's analogous to you switching on and off your switch. But in this case, it could take up to a second for your clock signal to say like, is my input high? Is my input high? Is my input high? And then it'll
does
relay that to the output.
Ha!
So,
that's so cool.
Yeah.
I love that. In the midst of all these, like, I know that you don't really focus on the electronics in your work, and you seem to be more about, like, you know, the whole vibe of it, the message, the design. But in this case, just focusing so much on the if it were a person, I'd say the embodiment, but the like electronic embodiment of the concept is so interesting. And I like, are these potted in resin, or is this sandwiched between plates, or?
No, they're just kind of like woven into acrylic and like soldered together.
Huh.
It's like stacks of acrylic, like mounted on a transparent piece, and then that's mounted on a like.
Yes.
I think I made this a while ago.
This is so cool. And so, how did you both get into electronics? Did you have formal training? Did you pick it up some way?
I think like the first time I studied computer science as an undergrad, but that was like it was like in the early 2000s. And part of the computer science curriculum where I went to school was, I feel like it was like not old school, but like maybe it was a little old school. And there was a course where they taught you like, assembly language, and like you had to solve problems in assembly. And then another part of that course was like building logic gates, which it didn't really like impact me at the time. But then when Say and I were both at ITP, that's when I was introduced to Arduino. That was the first time I was like, oh, like this is a thing. And like it brought me back to that world instead of like, I didn't really work with Arduino for a long time. Like at ITP, I actually like, I barely worked with Arduino. I became like very interested in the low level stuff instead of that. So that's kind of like where my interest started. I don't know, Say where's you?
I learned everything I know about electronics at ITP from Talmigo. Talmigo was my physical computing teacher, and before him, you know, I soldered some stuff in middle school maybe, but yeah, I had this like explosive moment in his class where we just got to mess around with Arduinos with his guidance, and you know, it was amazing because anytime we got stuck, I'd be able to knock on his door and be like, Tom, I can't get this thing to work. And then he'd sit with me and help me figure it out. And that was, it was super transformative. It made me, I felt super empowered. Like, you know, after one semester working with Arduino in his class, I was like, I think I can make anything we can imagine. So that was, that was really, really cool.
And he's one of the creators of Arduino, right?
Mm-hmm. Yep.
Amazing. I feel like this would be an amazing way to, and my brain is still on this project, and I feel like it would be an amazing way to introduce young people to electronics, or people who've never experienced like it before, and just understand sort of what the relationship is between like a button and like that. Oh, it's so good. Like so clearly highlighting the relationship between the speed of the CPU and like what it's actually doing. You have to evaluate the switch before the thing happens, you know, just like, very good. I love it. We are almost at the end of our time here. I want to give people a quick overview of all your stuff. We've got your Instagram page and your Twitter page that people can find linked in the description below. We have CW&T.com, which I may not actually still have directly up right now. Here we go. We have, of course, your super local Kickstarter. Is there anything else you'd like us to highlight before we wrap up?
No, I think that's everything.
Cool. Well, thank you so much for joining us. This is so cool. And I do recommend to people, actually, one last thing from me. I think that people should go watch this talk of yours, I wanted to ask you a bit about what you say in this talk about. You're going to get into the relationship between AI and human design, and I think that's got so much rich ground for talking about. But sadly, we can't do everything. We'll just have to come back on. So
okay, yeah, I mean, I'm very interested in this stuff, just tangentially. Like I know it's the future. So yeah, if people are interested in this stuff, you should read up on it.
I'm gonna go watch that talk. Everyone, this has been Che-Wei Wang and Taylor Levy of CW&T. Thank you so much for joining us.
Thank you so much for having us.
Thank you so much for having us. That was really fun. Thanks, Alex.
Sweet. Have a good one. Thanks everyone for joining. Bye.